Welcome to Spring LIB.
Hello friends, in the diagram it is a Robert linkage very approximation diagram is given to a straighten by locking a pin at point F. This is the point F. This is the point E, A, B, D, E. Now let us see it. The distance AB is same. Distance AB is same is equal to VF is equal to DF and DE, each of 12 inch. If var AB having a constant angular velocity, var AB having constant angular velocity of 4 radian per second in clockwise sense, then we have to calculate part A, angular acceleration of DE, and B part, acceleration of point F. So D, you have to find angular acceleration of DE, this part, and acceleration of point F. For vector rotation, remember it, this direction, for this direction we are taking I cap, for this direction we are taking J cap, for counterclockwise we are taking K cap. Now I start solving it. By geometry, RBA can be written as, see the figure, RBA can be written as 3I cap plus 12 square minus 3 square J cap. So RBA vector you will get 3I cap plus root 135 J cap inch R dB vector can be written as 6I cap or FV vector can be written as 3I cap minus root 135 J cap. All the values are in inch, so I am not writing again. You may use the, I am writing the unit here, unit for distance, inch, inch per second or inch per second square. So these units we are using. So we have written position vector of FV. Now position vector of DE minus 3I cap plus root 135 J cap. Angular velocity omega AB is given 4 radian per second minus K cap. for bar B, bar AB, velocity of V can be written as omega AB cross RVA vector. Omega AB is minus 4 k cap cross RVA 3 I cap plus root 135 j cap. So velocity of V you can write 4 root 135 I cap minus 12 j cap. I am not writing the unit. In the starting it is specified for object VDF. You may write velocity of D to be equal to velocity of V plus velocity of D with respect to V. So it can be defined as omega BD cross position vector of BD. Now substitute the value. Velocity of V already we have measured. So here we have to substitute. The velocity of D we will get velocity of V. So velocity of V is 4 root 135 I cap minus 12 j cap plus omega BD k cap cross 6 I cap. So velocity of D point we will get 4 root 135 I cap minus 12 j cap plus 6 omega BD k cross I, that is j cap. Say this is equation 1. Later on we have to use it. Bar DE. Now we calculate for bar DE. BD can be defined as angular velocity of DE cross position vector of DE vector. Now substitute the value. Omega DE k cap cross minus 3 I cap plus root 135 j cap. So on solving it, velocity of D you will get by minus root 135 omega DE I cap minus 3 times omega DE j cap. This is your second equation. If we compare equation of 1 and 2, you will get, first we compare the x component. On comparing the x component, we will get 4 root 135 to be equal to minus root 135 angular velocity of dE. So from here, angular velocity of dE, you will get 5 radian per second minus k cap, or in clockwise sense. And if we write the y component, if we equate the y component of equation 1 and 2, it would be minus 12 plus 6 omega Vd is equal to minus 3 times omega dE. Omega dE is 5. So from here, omega Vd you will get 4 radian per second minus k cap in clockwise sense. यहाँ पर by solving this equation I have written directly. You solve Vd substitute 15, transfer this, so you will get angular velocity omega dE to be just a moment. Now we have to solve for acceleration. Acceleration analysis. If we do the acceleration analysis, alpha av 0, because angular velocity is constant, var av, for var av you may write acceleration of v to be equal to cross rva vector minus omega square av rva vector. This is 0. Omega av is 4, so 4 square into 3 I cap plus root 135 j cap. So acceleration of v you will get minus 48 I cap minus 16 root 135 j cap. Now for object VDE, acceleration of D point, you may write acceleration of V plus acceleration of D in reference to B point, acceleration of V with respect to V, it will be alpha Vd cross Rvd minus omega square Vd Rdv vector. Here I have to make a correction, Rdv. Now substitute the value and find the expression for velocity of D. So velocity of D, we can write acceleration of D. We can write acceleration of D. Already we have calculated minus 48 I cap minus 16 root 135 J cap alpha VD. We are calculating K cap cross 6 I cap minus 4 square 6 I cap. So on simplifying it, and we can write acceleration of D point would be minus 144 I cap minus 16 root 135 J cap plus 6 alpha BD J cap. This is equation number 5. Now for the rod DE, acceleration of D, you can define it alpha DE cross RDE vector minus omega square DE cross RDE vector. Now substitute the value. So acceleration of D, you may write alpha DE K cap cross RDE is minus 3I plus root of 135 J cap minus omega square, that is 4. RDE is minus 3I cap plus root 135 J cap. So on solving it, acceleration of D, you can write minus root 135 alpha DE I cap minus 3 times alpha DE J cap plus 48 I cap minus 16 root 135. Just a moment, let me write properly. By solving equation 5 and 6, you can find the value of alpha DE and alpha BD that I am writing directly. So I'm not going to solve. You can easily solve by solving equations 5 and 6, equating x component and y component of both alpha DE. You will get 192 point root 135, and in vector notation it can be written as alpha DE 16.53 K cap and alpha BD minus half of alpha BD. So this value will be minus 96 upon root 135 So in vector notation, alpha BD can be written as 8.26 minus k cap. Now angular acceleration of bar DE. So this is your first answer, 16.53 radian per second square in clockwise direction. So this is the one of the answer we have opted. Now acceleration of F point. Let me change the color of the pen. Acceleration of point F. So AF can be written as AV, AFB. So it would be AB plus alpha BD cross RFD minus omega square BD position vector of RFD. Now substitute the value. So acceleration of F point will be 48 I cap minus 16 root 135 J cap plus 96 upon root 135 K cap cross 3 I cap minus root 135 J cap omega square 4 square into 3 I cap minus root 135 J cap. After solving it, acceleration of F point you may write minus 192 I cap minus 288 upon root 135 J cap. Answer will be in inch per second square. So this is the answer of B part of this problem. Very lengthy calculation in it. B. Do it patiently. Few steps I have skipped out because it is very difficult to write. Thanks for watching it.